Okay, now in this mini lecture, I'm just going to spend a little bit of time on this ORIS example from pages 197 and 198. What I mostly want to focus on here, though, is trying to help develop your understanding of this partitioning of the variance into error variance and to treatment variance. So if you look here at the top, this is the example that ORIS provides in the book. Okay, and so for Alpha tires, the average was 51,000 miles. For Delta tires, the average was 46,830 miles. And then where I talk about partitioning total variance into error and treatment, you can see that right here. Okay, let me see if I can make that a little bit larger once. Okay, so this minus 9.45 value is simply 46, the observation for vehicle number 1 and group number 1. It's just 46 minus the group mean, and you can see the group mean, I'm sorry, the grand mean, and you see down here that the grand mean is 55.45. So the total variance to be accounted for here, is 9.45. That's the difference between the observation 46 and the grand mean, which is 55.45. Okay? Then what we do is we partition this total variance. We partition, or I should say this total deviation. We partition this total deviation into two groups. One having to do with what ORIS refers to as error, and one having to do with what ORIS refers to as treatment. For the error, we simply subtract the observation, so this is vehicle number 1 in group number 1, and we subtract from this observation the group mean for Alpha tires, and we've got the group mean down here, which is 51,000 miles. So the way that we get this minus 5 is just 46,000 miles minus 51,000 miles, the group mean. And if you look at the spreadsheet file, which is out on Blackboard, you can see the formulas to reinforce what I say here. And then the group mean minus the grand mean. Well, the group mean and the grand mean, that information is down here. So the group mean is 51,000 miles, and the grand mean is 55,450 miles. So this minus 4.45 here is just 51,000 miles, the group mean, minus the grand mean of 55,450 miles. And that's where you get the minus 4.45. Every row in this file has exactly the same partitioning of the total dispersion. Minus 11.45 is just vehicle number 4 in group 1, which has got 44,000 miles, minus the grand mean of 55,450 miles. So the total deviation to be accounted for is 11,450 miles. 7,000 of that is attributable to what we call error, and 4,450 miles of that is attributable to treatment. And again, the way that we got this treatment value, if you notice, all the values for Alpha have the same treatment. All of the vehicles for Beta have the same treatment value. Same for Gamma and so forth, okay? Because every vehicle in Alpha, the way that we calculate that is the mean for the group minus the grand mean. So the mean for the group minus the grand mean is the same for every vehicle in the group. Same way with Beta. Okay? Every vehicle in Beta is equal to the mean for Beta minus the grand mean. So where do we get that 8.3? The mean for Beta is 63,750 miles. The grand mean is 55,450. So 63.75 minus 55.45, that's equal to 8,300 miles. All right. So I want you to begin to see when I talk about partition the variance, this is the total variability or dispersion to be accounted for. And then we partition this total variability into the deviation from the group mean and then the group's mean from the grand mean. When you get down to the bottom of it, and I want to emphasize, that works here, but it doesn't work here on a line-by-line basis, because when we square the deviations, whereas if you'll recall from earlier in the semester, the deviations always sum to 0, but when you square the deviations, they don't sum to 0. So if you say, well, wait a minute, 89.39 is not equal to 25 plus 19.84, it's not supposed to equal 0. If it did, we would have some serious problems there. However, when you get to the bottom of the page, let me do something. I'm going to see if I can freeze this title. How would I do that? Page layout, maybe view, freeze panes. Okay. When you get to the bottom here, okay, you see that our total, the sum of our deviations is 0, but there's a routine in Megastat that allows us to to square those deviations. So we see that whereas the sum of our deviations is 0, the square of those deviations is 1865. Whereas the sum of our deviations from the group mean is 0, the square of those is 800. And whereas the sum of our deviations between the group mean and the grand mean is 0, the square of those is 1058. And you see here, when you sum these, 1865.45, that's equal to 807.01 plus 1058.44. Same way over here, where we actually have squared everything. So this is kind of our check of arithmetic, where these are equal to these. That tells us that we've done our math correctly. Okay? And even you might say, well, why in the world would I ever have to know anything about these? Okay? Well, the sum of squared total, sum of squared errors, and sum of squared treatment, if you follow them over here, that's how we build the ANOVA table. Okay? So again, the beauty we have is we don't need to build the ANOVA table to eventually get to the p-value. We're going to let the computer do that for us. But I do want you to understand, at least conceptually, what we mean by partitioning the variance, and the fact that even though we don't have to do these calculations in ANOVA, because the computer does them for us, the reason why partitioning matters is because that's how we eventually get to the p-value for our data. Now, one final thing that I want to show you is, notice here, let me change the size of this just a little bit once. If you notice here, the grand mean and the group means on this sheet all equal the grand means and the group mean on the previous sheet that I just covered. But look what's different here is that I have no within group variance. All of the alpha vehicles got 51,000 miles on those tires. All of the beta vehicles got 63,750 miles. All of the gamma vehicles got 61,286 miles. So here we have no within group variance. For alpha, we have no within group variance for beta, we have no within group variance for gamma, and we have no within group variance for delta. So look what happens here. Now what we have is our total deviation to be accounted for. In the case of the first car in the alpha group, we have to account for 4,450 miles of total deviation. None of that is attributable to within group variance. It's all attributable to treatment. And notice how every vehicle, because we have no within group variability, all of these cells for alpha are the same. Let's go down and look at beta, or I'm sorry, at gamma. Same way for gamma, okay? The total deviation from the grand mean that we need to account for is 5,830 miles for the first vehicle, the second vehicle, the third, the fourth. All of the vehicles that had gamma tires, they had the same amount of total variability. None of it is attributable to within group variance. All of the variability is attributable to the treatment, okay? So when we talk about within group variance and between group variance, I hope this screen shows you that the reason why, let me go back to this sheet, the reason why we have within group variance is because not all of these vehicles have exactly the same number of mileage, not per set of tires. Not all of these vehicles have exactly the same miles per set of tire. So within group variability is caused when not all of your vehicles within a group are the same value. Your between group variability is caused when your group means are not equal to your grand mean. If all of the groups, alpha, beta, gamma, delta, if all of these groups were exactly 55,450 miles, there would be no between group variance, okay? And again, I'll take you back to this example here. This is an example where there's no within group variance because all of the vehicles within each group got exactly the same miles per set of tires. So within group variance is eliminated when there's no variance within the groups. Between group variance would be eliminated if each of the group means is equal to the grand mean. And what we do in ANOVA is we partition variance between what we call error variance, or how much variability is there within our groups, and we compare that to variance between the groups, which is accounted for the difference between the grand mean and each of the individual means. Each of the group means. If all of the group means was 55,450 miles, there would be no between group variance, or SST would be 0. I hope that helps.